Okay, we're going to find in this section what the relationship of the areas or the volumes of two similar solids is. So the first thing we need to recall is what are similar solids. So two solids of the same type, so when we say same type we mean, are they both cylinders, are they both spheres, are they both pyramids? Two solids of the same type with equal ratios of corresponding linear measures such as heights or radii are called similar solids. And the common ratio is called the scale factor. You may or may not recall that we call the scale factor A to B or A over B. And just a reminder, if you had, let's say, two rectangles, and this was 2 and 6 and this was 4 and 12, then these two rectangles are similar and their scale factor, or what we call common ratio, would be 2 over 4, going from the smaller to the larger, which is 1/2. And if you see, 6 over 12 is 1/2. So all linear measures are in the same ratio. In the case of solids, there's a three-dimensional aspect to it. And if you look at these two cylinders, you're given the radii, or rather the diameters here, but you're not given the heights. So if the heights were, let's say, 16 and 20, then 8 over 11 would not be equal to 16 over 20. So we would say they are not, cylinders are not similar. What if and of course we should include the units. So now I have the situation where I have 8 over 11. Notice you go from one cylinder to the other. You don't do 8 over 16 equals 11 over 22. You go 8 over 11 is equal to 16 over 22, and I see that on the right hand side I could reduce this to 8 over 11. So they're both similar, therefore the cylinders are similar. And this is what we are going to focus on. This is what we're going to focus on. When solids are similar, what is the relationship between their areas and their volumes? Okay? So the theorem says that if you're given that two solids are similar, so we are saying that if these two cones are similar, and we're given that they're similar, then the ratio of the two radii is the scale factor. So in this case, you would say that the scale factor, which is A over B, is equal to 4 over 3. Well, let me rewrite it another way. A over B equals R1 over R2, which is 4 over 3. Now, A over B squared is the ratio of the surface areas. So that would be 4 over 3 squared, which is 16 over 9. And the ratio of the volumes is equal to A over B cubed equals 4 over 3 cubed, which is 164 over 27. And this is useful if you were given the volume of one of the solids and you needed to find the volume of the other one. So you would just plug in, if you were given the volume of one, you would just plug all the stuff that you know, all the variables that you know, not all the stuff that you know, and solve for whichever volume you didn't know. I am just going to do a problem over here. So, and this is what, let's say you're given volume 1 is equal to 125 units cubed, and volume 2 is equal to 27 units cubed. You want to find the scale factor. So what you would do is V1 over V2 is equal to A over B cubed. So you go ahead and plug the numbers in. 125 over 27 equals A over B cubed. Now I want you to take out your calculators. And what you do is, in order to find A over B, you're going to find the cube root of both sides. I'm going to do that in a different color. So you are doing the cube root, and cube root is the same as the exponent 1/3. So you would now have A over B is equal to 125 over 27 to the exponent of 1 over 3. So how do you put this in your calculator? What you would do is you would put 125. So here's what you do on your calculator. You would enter 125 divided by 27, put that in parentheses, then you use the caret and you put 1/3 in parentheses. So what you're doing is you're raising 125 over 127 to the exponent 1/3, and you should get 5 over 3 as the answer. So check that out. You want to know how to use your calculator. So your scale factor, A over B, is equal to 5 over 3. I'm sorry, I'm having to squeeze this in a little. Let me move down here. So your scale factor is okay, and let me rewrite it. A over B equals 5 over 3. And if I needed to find the ratio of the areas of these two solids, then I would just do A squared over B squared. And when I say areas, I meant the surface areas. Alright, let's look at these problems. Okay, so you have cylinders A and B. This is cylinder A and this is cylinder B. So check to see if the radii of the two are, and the heights of the two are in the same ratio. When I mean two, I mean cylinder P to A and P to B. Oh, these are very nice looking beach balls, and they say they are similar with the scale factor. So I find the surface area that is pretty of the similar ball. So you do need to know, I believe, no, you don't need any other information. Okay, continuing forward. I got a little confused there. So this is just so that you don't get it. This is given to you, okay? And what you want to do is you want to find call this S1 and V1 of the smaller sphere, okay? Or the smaller ball. Okay, for this one, you are going to employ the method that I showed you just a short while ago, and I think that's eminently doable. Word problem. So let's look at the word problem. Garden store sells gravel in boxes that are cubes. So cubes, any two cubes will be similar. What I would do here is say let x equal to edge of larger cube. Therefore, edge of smaller cube is equal to 3/4 of that. Okay? So now their ratio, figure that out. Figure out what A over B is, and then I think you can go from there. Don't be intimidated just because you don't have a measurement. The x's should cancel out, so go ahead and try that. Okay, these are the answers. So good luck.